Hi everyone, it's Calculus by Christee, and in this video I'm going to go through a free response question that was on the AP Calculus exam in 2021. One of the best things you can do to prepare for the AP Calculus exam is to practice free response questions from past exams. In the description below, I've provided a link to College Board's website where you can find this question along with scoring guidelines and even sample responses. I will be bringing you free response practice until the AP exam, so make sure to subscribe to see those upcoming videos to help you prepare. And comment below about any questions you have, and check out the rest of my channel for videos on various calculus topics. Let's get started. Here is question number 2 from the AP Calculus exam, and this one you can use your graphing calculator on. So let's take a look. A particle P is moving along the x-axis. The velocity of particle P at time t is given by this sign equation. So remember, that's the equation for the velocity of particle P, and that equation is good for a time value between 0 and pi. At time t equals 0, particle P is at position x equals 5. And then we've got the second particle Q that also moves along the x-axis. Its velocity equation is given, again, for time values between 0 and pi. And at time t equals 0, particle Q is at an initial position of 10. So part A asks us to find the positions of particle P and Q at time of t equals 1. All right, so let's first start by finding the position of particle P at a time value of 1. So that would be my notation there. So what I need to do to find the position at a given time is I have to start with the initial position. So they told us at t equals 0, particle P is at 5. So particle P started at 5, and then we have to add on how the position changed from a time of 0, when we had our initial position, to a time value of 1, which is what we're looking for. So to find that change in position, we need to calculate the integral from 0 to 1 of the velocity equation. And because the velocity equation is given in the problem, I'm just going to write out in my work just Vp of t dt to find that. And then we just have to calculate what this is. So at this point, I would go to my graphing calculator and I would find this value. So we've got our initial value of 5, and then I need to add on the integral. So that would be under the math button. And you can go down to number 9, or you can just press 9. And we are taking the integral from 0 to 1 of my velocity equation, which in the problem was sine of, don't want to press second, sine x, or t, to the power of 1.5, and that was dt or dx. And you know what? I think I am missing a parentheses. Not that I don't know if it would make a difference, but I'm going to go ahead and go back and add that. Okay, so I think that is going to be our final position, or our position at t equals 1 for particle P. Remember, if you are taking the AP exam, you always want to round or truncate to at least 3 decimal places. So I'm going to round in this one, and I'm going to say 5.371. And then I always like to write a sentence for my answer. So here I would say, at time t equals 1, the position of particle P is 5.371. Now let's move on to particle Q. So here I would say the position of particle Q at a time value of 1 is going to be equal to its position at the starting time, which was 10, plus the change in position from 0 to 1. So that means I'd be taking the integral of the velocity equation once again to find the position of particle Q at 1. So I'm going to do the same thing, and I'm going to plug this into the graphing calculator. And I got an answer of 8.564. And once again, I'm going to write my sentence. At time t equals 1, the position of particle Q is 8.564. Now on to part B. Part B reads, are particles P and Q moving toward each other or away from each other at time t equals 1? Explain your reasoning. So to know whether two particles are moving towards each other or away from each other, we need to figure out their positions and their velocities, because velocity will tell us which direction these particles are moving. Well, the good thing is in part A, we already found their positions at a time value of 1. So just to recap, the position of particle P at a time value of 1 is 5.371, and the position of particle Q at a time value of 1 is 8.564. So then, like I said, I need to evaluate their velocities. So I need to evaluate the velocity of particle P at an x value of 1, or sorry, a t value of 1, I should say. And for that, I'm simply going to use my calculator and plug in a time value of 1 to evaluate the velocity of particle P at 1. And for the velocity, I get 0.841. Now, because this velocity is greater than 0, I know particle P is going to be moving to the right, and we'll show a little visual of this in just a minute. So the next thing I have to find is I have to evaluate the velocity of particle Q at a time value of 1. Once again, I'm just going to go up to its velocity equation and plug this into my calculator and plug in a time value of 1 to evaluate this. And I get a velocity of -1. And you can see that that velocity is less than 0, which means particle Q is going to be moving to the left. So if I kind of did a little visual here of what's going on, let me put a little number line. And I can see at a time value of 1, particle Q has a position that's greater than particle P. So particle Q is going to be right here at a position of 8.564, and particle Q, because particle Q has a negative velocity, particle Q is going to be moving to the left from a position of 8.564, whereas particle P is at a position of 5.371, and because particle P has a positive velocity, that means particle P is moving to the right. So just by my little kind of picture here on my number line, I can see that particles P and Q are moving towards each other, but now I'm going to explain my reasoning in a sentence. At time t equals 1, particle P is at position 5.371 and moving right, and particle Q is at position 8.564 and moving left, so the particles are moving towards each other. Now on to part C. Part C says, find the acceleration of particle Q at time t equals 1. Is the speed of particle Q increasing or decreasing at time t equals 1? And once again, explain your reasoning. So first, I'm going to find the acceleration of particle Q at a time value of 1. To do that, that means we need to find the derivative of velocity to get acceleration. So for my notation, I would say we are finding the acceleration of particle Q at 1, which is the same thing as finding the derivative of particle Q at a time value of 1. And once again, because I can use my calculator, I'm going to calculate this derivative and everything right in my calculator. And just a reminder of how to do that, what you're going to do is you're going to press Math 8. That's going to give you the derivative function. I'm calculating the derivative in terms of t, but I'm going to use x, and I need to type in the velocity equation of q. And then I need to say I want to evaluate this derivative at a time value of 1. And you can see here I would get 1.027 for the acceleration. And then the question says, is the speed of particle Q increasing or decreasing at time t equals 1? For this part, we need to compare the signs of velocity and acceleration. So in part B, we found that the velocity of particle Q at a time value of 1 was -1, which is less than 0. Then in part C, we found the acceleration to be 1.027, which is greater than 0. If acceleration is positive, but velocity is negative, so if velocity and acceleration have opposite signs, I kind of think of that as they're working against each other, and therefore the speed of particle Q would be decreasing. So whenever the signs of velocity and acceleration are opposite, the speed is decreasing. And if the signs were the same, so let's say they were both positive or both negative, then particle Q, the speed would be increasing. So let's write this as a sentence. The speed of particle Q is decreasing at time t equals 1 because the acceleration at time 1 is greater than 0 and the velocity at time t equals 1 is less than 0. And by the way, if you're finding this video useful, make sure to click subscribe and give it a like so that you can see future calculus videos and future AP free response questions that are coming up in the coming weeks. All right, now on to the final part, part D. Find the total distance traveled by particle P over the time interval from 0 to pi. Now, to find the total distance traveled, we use an integral, and then we take the integral of the absolute value of velocity. Taking the integral of the absolute value is going to account for either the velocity moving or the particle moving left and right, and it's going to add up the total distance and not just find the displacement or counteract the positives and the negatives. All right, so from here, I would just plug this in my calculator using math option 9. Also, remember to get the absolute value, you would press Math, go over to NUM at the top, and click the first option, which says ABS. And I got an answer of 1.931. And writing that as a sentence, I would have, over the time interval from 0 to pi, the total distance traveled by particle P is 1.931. All right, everyone, I hope you found this video helpful with helping you with question number 2 from the AP Calculus exam. If you did, make sure to give it a like and subscribe so that you're notified of future problems that are coming out that'll help you with free response questions from past AP exams. All right, everyone, good luck on the AP exam if that is coming up soon for you, and we'll see you in the next video. Bye, everyone.